Hi, welcome to another tutorial video on Python programming. I'm doing this tutorial as the next revision challenge in my series of Python tutorials, and in this challenge what I want you to do is to create a program to solve a quadratic equation. So I want a program that takes inputs for the coefficients of x and the constant term, so in this form here, the quadratic equation, and then outputs the solutions. And if it's only got one solution, I want it to tell me that it's only got one solution and output that solution. And if it's got no solutions, I want it to output no real solutions. Obviously we could extend the program to print out complex solutions, but that's a bit beyond the scope of today's tutorial. Okay, I'll give you a few moments to pause the video and attempt the solution, and then I'll go for it. Okay, so there's lots of ways you could solve this, but I'm going to just show you one way in which I've used functions as far as possible to modularize my program and make it much easier to understand what's going on. So first of all, I'm going to import math, because we're going to need that to take the square root of a number. I'm going to create my first function, and this function is going to be used to get the coefficients from the user. So I'm going to call it get coefficients. And it's going to take no arguments. I'm going to create a variable called x squared coefficient. I'm going to set that equal to a float and of an input, and that input is going to be enter the coefficient of x squared. So that's going to allow my user to enter the value of their x squared coefficient, or a. I'm going to create another variable called x coefficient. I'm going to set that equal to the float of an input, enter the coefficient of x. I'm going to create a final input, and that's going to be to get the constant term from the user. So our C term in the equation up here. Okay, so those are my inputs. Those will allow the user to enter the values of the coefficients of x, of the x terms, and the constant. What I need to do though is return all of these to my main program, because I'm going to want to use those variables in my other functions. So I'm going to type return x squared coefficient, x coefficient, and constant term. So I'm going to return those variables to my main program. And the advantage you can start to see of using functions in this way is you can easily see that that is the code that's going to get the data that we need to solve the equation from the user. So I'm also going to define a function for my main program here. And this is going to be where we call all of our functions from. So first of all, I'm going to call get coefficients, because that's the first step to solving a quadratic equation programmatically. X squared coefficient, x coefficient, and constant term. I'm going to set that equal to get coefficients, and that will set those variables in our main program equal to the values that get coefficient returns. Next off then, I'm going to define a new function. and this is going to be the function to calculate the discriminant. And if you know, if you've studied the quadratic equation in maths, then you'll understand what I'm on about. If you haven't, I'll put a link in the video description where you'll be able to get some information on that. So I've got a function called calc_discriminant. I'm going to pass in my values that I've got for my coefficients of x and the constant term. So first of all, then, when I calculate the discriminant, I'm going to need to square the x term. So the coefficient of x, rather. And this is because the discriminant is equal to b squared minus 4 times a times c, where a, b and c are the values in this form of the equation. So that's what our discriminant there. So the first step is to calculate what b squared is. So I'm going to define a variable to store b squared. I'm going to set that equal to the x coefficient that we've passed in, and then a double star, and what that means is raised to the power. So that raises x coefficient to the power 2, if we type 2 there. So that just calculates the square of this value that we got from the user. So the next step in calculating my discriminant is to calculate this part, the 4 times a times c. And I can define another variable to store that. So I'll define another variable to store that, 4ac. So I'm going to type 4 times the x squared coefficient that I passed in, times by the constant term that I passed in. And that will calculate the value for 4ac. And then all I do is take this value away from this value, and that's my discriminant. So I'm going to define another variable called discriminant, and I'm going to set that equal to the square of x coefficient minus 4ac. And I'm going to return the discriminant to my main program. So that's another function to calculate the value of the discriminant of our quadratic equation. So I'm going to call that function from my main program now. What I say is discriminant. That's what we want to get out of this function. Equals calc discriminant x squared coefficient, x coefficient, and constant term. And that will calculate our discriminant and return it back to the main program. And now we need a new function. And this next function is going to be to check the number of solutions to our quadratic equation. And if you, as I say, if you've studied quadratic equations, you'll know what I'm talking about. Depending on what the value of our discriminant is, we'll get a different number of solutions to our quadratic equation. And we need to know that to make sure that our program doesn't crash when we put in certain quadratic equations. So I've defined another function then called checkSolutionNumber, and I'm going to pass in discriminant. And I'm going to say if the discriminant is less than 0, I'm going to set a new variable, number of solutions, equal to 0. And then I'm going to say else if, so elif in Python, discriminant is equal to 0, number of solutions equals 1. And then else number of solutions equals 2. And I'm then going to return the number of solutions back to my main program. So I'm going to call this function from my main program now. I'm going to want to get the number of solutions out of it. So I'm going to set number of solutions equal to check solution number, and I'm going to pass in the discriminant so we know what that is, and that will find out the number of solutions to our quadratic equation and return that number of solutions back to our main program. So the next part, the next function that we need is a function to actually calculate the final solutions to our quadratic equation. So I'm going to define a function calc solutions, and then I'm going to pass in the x squared coefficient, the x coefficient, the discriminant, and the number of solutions, and that's all we need to calculate our final solutions. So what I'm going to do then to calculate my final solution is the first part of the quadratic formula is minus b. So we're going to find out what the negative version of the x coefficient is. I'm then going to double the x squared coefficient because we need to divide the numerator in the quadratic formula by 2 times the x squared coefficient. And this is the bit where we need to use our numbers of solutions now, because if the number of solutions is equal to 2, we're going to need to calculate the solution twice, because we're going to have 2 different solutions. If the number of solutions is equal to 1, we're only going to need to calculate the solution once. And if there are no solutions, we're not going to want to do the square root, because we're going to get the square root of a negative number. And unless we're extending our program to handle complex solutions, we're not going to want to be doing that. So I'm going to say if number of solutions equals 2, the square root, so root of the discriminant, is equal to math dot square root. This is where we're going to use the math library and put in discriminant as an argument. I'm then going to create a variable for my first solution and set that equal to the negative x coefficient, which is the first part of the numerator on my quadratic formula rather, plus the square root of the discriminant divided by the 2 times a, which is double x squared coefficient, and that will give us our first solution. We can then do the same for our second solution. We will copy this line, but then instead of having it be negative x coefficient plus root discriminant, we want it to be minus. We then want to say else if the number of solutions is equal to 1, we're going to work out the first solution again, just as normal. And then, because there's only one solution, we're going to set the second solution variable equal to exactly the same as the first solution. We're also going to need to find the square root of the discriminant again before we do that. And then our last part of the if-else statement, I'm going to say else print else solution 1 equals not real, and solution 2 equals not real. Okay, so that's the full code for how we would calculate the solutions to our quadratic equation. All I need to do now is return the solutions back to my main program. I'm then going to call the function in the main program, and that will calculate solution 1 and solution 2. Now all we need to do is display the solutions to our user. So I'm going to define a new function to do that. I'm going to call it print solutions. I'm going to pass in solution 1, solution 2, and the number of solutions, because we're going to want to print a different thing depending on how many solutions there are. So I'm going to say if number of solutions is equal to 2, print out the first solution. So print the first solution is, and then plus string of solution 1. And then we're going to print out the second solution. So then I'm going to say elif. So else if the number of solutions is equal to 1. I'm going to say print there is only one solution which is, and then just print out solution 1. Solution 1 and solution 2 are the same thing. I'm going to say else the equation has no real solutions. Okay, so I'm now going to call print solutions from my main program. So print solutions. I'm going to pass in solution 1, solution 2, and number of solutions. And then I'm going to make sure to call my main method in the main body of the file. Okay, so if we run this program then and test it out, it asks us to enter the coefficient of x squared. So if we test out our program then with the equation with a being equal to 1, b being equal to -2, and c being equal to -4, we should get 2 solutions. And we do. We get these 2 solutions, which if we have a look at the solution to the equation on Wolfram Alpha, we can see that these 2 are the correct solutions. So I've got one that has 1 solution here. The coefficient of x squared is 9. The coefficient of x is 12. And the constant term is 4. And that's given us our 1 solution. If we have a look at that solution on line, we can see that that is indeed the correct solution that our program's given. Let's test our program in one more case when the quadratic equation has no solutions. I've got an equation here that has no real solutions. The coefficient of x squared is 3. The coefficient of x is 4. and the constant term is 2. So this should produce the message, the equation has no real solutions. And it does, so the program works. Okay, so that's how you solve that revision challenge, creating a program to solve the quadratic equation. I'll be interested to know if anyone can find a more efficient way of doing this or a different way of doing this. If you can, post a link to it in the comments. Thanks for watching.